Hi, everyone. My name is Alex Bastavros. I'm a senior product manager with Amazon Web Services. And today I'm here to talk about how you can lower costs with Amazon's EC2 T3 general purpose burstable instance types. We're going to first cover a quick overview of our EC2 instances. Then we're going to dive deeper into our T3 and T3a instance families. We're going to talk about some of the target workloads, go over some FAQs, and then do a Q&A. So first off, our EC2 instances. EC2, we offer the broadest and deepest platform choice. As you can see from the slide, we have multiple categories where we actually purpose-build our EC2 instance types, including general purpose, burstable, compute intensive, memory intensive, and so on. And within those families, we offer a variety of capabilities, including different choices of processors, including AWS, Intel, AMD, very fast processor types up to 4 gigahertz, and high memory footprints up to 12 terabytes. And then we have all these additional options and services to add on to your instance type, including Elastic Block Store for your storage, Elastic Graphics for your graphics needs, and Elastic Inferences, all of which can be added to your instance type. So this really gives you over 200 instance types, so virtually giving you something for every workload and business need. So we've been able to iterate very quickly and offer a whole bunch of different EC2 instances by using the AWS Nitro System. That's what's enabled this rapid pace of innovation. We started on this effort several years ago to completely reimagine our virtualization infrastructure with what we call the Nitro System. The Nitro System includes three major components. First is the Nitro card. The Nitro card is what enables us to offer the local NVMe storage, so very high speed, low latency storage, the connectivity to the Elastic Block Storage Service, or EBS, and also the networking, monitoring, and security that you come to expect with EC2. Then there's the Nitro Security chip. So this Nitro Security chip is integrated into the motherboard and protects all the hardware resources within EC2. And then we have the Nitro Hypervisor. So this is a lightweight, purpose-built hypervisor that limits the number of memory and CPU allocation to all the customers and offers you bare metal-like performance. So these modular building blocks are for rapid design and delivery of all the different EC2 instance types in our latest generations. So I want to focus in a little more on what we call our EC2 Core Platforms. So these are platforms that are very general in use, where you can use these across several different workloads. So first off, the compute optimized. These are very popular instance types, especially for customers that need the highest CPU performance. So our Z1D offers up to 4 gigahertz, the fastest processors in the cloud. And then we have our C5 instance type, which offers a very high performance core platform targeted at those high performance workloads. In our general purpose family, this is where we think about the balance, giving you, fast CPU, a good amount of memory, and a lot of network connectivity. So this is what we call our M5 family, or our multi-purpose family. Our T3 and T3a are burstable instances, and our A1. These are built on our AWS Graviton CPUs. And then we have our memory optimized. So these offer us the highest vCPU to memory ratios in EC2, starting with our high mem family, which goes up to 12 terabytes, purpose-built for large services like SAP HANA. Our X1, X1E family, offering you 16 gigs per vCPU with X1, or 32 gigs per vCPU with X1E. Those go up to 4 terabytes worth of memory. And then our R5 and R5A family, offering you 8 gigs per vCPU. Today, I really want to focus in on our T3 and T3a instance types. So these fall within our general purpose bucket, meaning they're going to apply to a large number of workloads that are run in the cloud today or are running on-prem and could migrate or are thinking to migrate to the cloud. So these are going to be very useful for customers who are already in the cloud and are working to migrate to the cloud. So let's talk about Burstable and what that actually means. So the key question to ask yourself when picking your instance type is how much performance do you need? So this graph on the chart shows that the CPU utilization over time is fairly consistent. You have a very deterministic workload where you need a continuous fixed CPU usage. This could be a server that has a very fixed traffic level. This could be a simulation that's constantly running. So you're constantly seeing those CPU resources be used, which works well because you're paying for them and you want to use what you pay for. On the other side, this has been a larger number of workloads actually have these variable peaks in CPU usage. This could be a lot more random in nature. So say if it's maybe an internal server that you have running and someone accesses it only a few times a day. So you might see a couple different spikes. This could be an external workload where you have some service or mobile app that only gets used during peak hours, maybe after work, where people want to check the news, for example. So that's where you see some of these peaks. But the rest of the day, the instance actually sees very little usage and there's not much going on. So one of the opportunities that we saw talking with our customers is that having to pay for this fixed CPU usage can be quite expensive, especially if your workload profile is more like the graph on the right. So one of the things that we tried to do with the burstable instance types is to get you to pay for what you need. So have you checked your CPU utilization? So if you can see here on the chart, if you actually look at the number of instances that actually use up a high amount of their CPU, it's going to be on the right side. So very, very, very few instances actually get to use all the CPU on an average. Where you see this big bundle of instances on the left, relatively way underutilizing the compute. And these are instances that are actually paying for it. So there's an enormous opportunity here to leverage something like the burstable instance types to then save money and get better utilization. So if you want to check to see if you fall into this category, it's very easy to check. I'm going to show you a quick example here using the AWS console. So if you go to the AWS console, navigate to EC2, and then pick on instances. And if you click on one of the instances, like I have here on the screen, you can actually go to monitoring. AWS and EC2 offers a service called CloudWatch, which allows you to look at the different statistics of your instance. So if you click on monitoring, you're going to see one of the graphs is called CPU utilization, along with, here we have some disk reads and disk read operations, as well as a whole bunch of other metrics that you can go look at. So this is a very useful tool, especially if you're running a new workload or a workload that you used to run on-prem, you're running in the cloud, and you want to make some comparisons or even understand the profile of your workload. If you click on the CPU utilization, you can actually go to the CloudWatch monitoring details. I suggest, given the relevance to the burstable instance types, the way to look at CPU utilization is actually on an average. And you want to look at over a day. So this is going to be the right number to make the judgment of which, or number one, is the burstable instance type right for you? And then which burstable instance type will be the right one for your workload. So this one, I'm looking at an M5, which is our general purpose instance type. And what I wanted to do is see over the day that it's been running, what is my average CPU utilization? You can see here it came in around 15%. So that means on average, 85% of the CPU was not used in that day. So burstable instances. So these are cost-effective instances for most general purpose workloads. They're going to offer a generous baseline performance and automatically burst up to the full core performance as needed. And you can burst whenever you want and for as long as you want, making it a very similar experience to a general M5 instance type, for example. So let's talk a little bit about the burstable instance family and how it evolved before we dive into some more of the details. So the first burstable instance type is called T1 Micro. This was launched back in 2010, so over 9 years ago. We followed that by T2, offering more sizes and a more advanced hardware configuration, offering micro, small, medium, and large. Then we found that there was a need for even smaller instances for those really, really small jobs where you want to make them super cost effective. We launched a T2 nano instance type a year later. And then on the other end, we found, talking with our customers, that there was a need for larger sizes, making this a lot more applicable to some of the heavier workloads that are migrated to the cloud and making them very cost effective. So we offered extra large and 2x large. And then we launched a service called T2 Unlimited. So T2 Unlimited is what enabled the instances to burst up to unlimited CPU for as long as they need it. And we're going to talk a lot more about unlimited in this presentation. And then we followed that up a year later with T3. So T3 instances launched in Q3 of 2018. And these are our latest generation instance types. And we have our T3a instances, which we followed up with this year. So the T3a offers the AMD EPYC processors compared to T3 with the Intel Xeon processors. And the T3a's costs an additional 10% lower price, offering an even more cost-effective price point. And we have a lot more innovation in this family that we're going to be releasing here soon. So let's talk about the EC2 Burstable T3 instances. So T3 had 30% improved price to performance compared to T2. This was largely due to innovations that we did on the Nitro system, which we introduced earlier in this presentation, as well as the latest generation Intel Xeon processors that we got from Intel. So combination of these two were able to offer significant improvements in the performance, and then obviously with the reduced price point of our T3 instance family gives you a nice 30% improvement when you're looking at price performance. So as I mentioned, T3 features the latest Intel Xeon Platinum 8000 series processors, previously codenamed Skylake. And then we had the T3a instance types offering an additional 10% lower price point with the AMD EPYC 7000 series processors. So with T3 and T3a, especially for customers who have been using our T2 instance types or the previous generation, the unlimited CPU burst setting is now set by default. For T2, that was actually an opt-in. For T3, it's the default, and you can revert back to standard mode if you so choose. You get twice the number of eCPU on these smaller instance sizes with T3 when compared to T2. And then the T3 instance types are available very broadly in up to 25 AWS regions globally. And these are all built on our new AWS Nitro System. So both the T3 and T3a are going to offer a very similar experience with the Nitro System. So giving you that same Nitro System across the T3 and T3a, as well as the M5, R5, and C5, and all of our latest generation instance families. So with T3, we also improved the network performance. So now we run up to 5 gigabit per second at burst. You use the high performance and high availability EBS or Elastic Block Store for the storage on the T3 and T3a instances. And we also improve the EBS performance. So now we offer up to 1.5 gigabit per second on the smaller sizes and up to 2.05 gigabit per second on the larger sizes for our EBS bandwidth. So providing more speed. These are a lot of requests that came through as customers started utilizing our T instance types. So they needed a little more performance to get to the disk or to the network. And these are a lot of the improvements that you're seeing on the T3 and T3a instances. So here are the different sizes that we offer. Our smallest size is nano. So these give you 2 vCPUs and half a gigabyte of memory. You can see here we have a column called optimized for CPU usage. So what this means is on that chart that we walked through earlier about tabulating what your average CPU utilization is over 24 hours, if you're less than 5% and you're on a 2 vCPU system, less than 5% is where you want to look at nano. That means it's a super, super light workload that rarely needs to be accessed, but you need it to be on and highly available. Nano is going to be the best option. Now, these go all the way up to 8 vCPUs with our 2x large size and a memory size of 32 gigabytes. And you can see how the EBS burst bandwidth and the network burst bandwidth. The network burst bandwidth is 5 gigs across the board, but the EBS burst bandwidth can go from 1.5 to 2.3 on the larger sizes. And a quick note between T3a and T3. So T3a are our latest T3 instance types. These are the ones with the AMD processors denoted by the A. You actually get one-to-one size mapping, so making it very easy for your selection, especially if you're a T3 customer today or you're a T3a customer. You can actually move back and forth between these two as it offers the same size, the same Nitro system, and the same instance characteristics. So depending on what you need, you can actually save even more money going to the A's, or if you're a little more performance focused, the T3s might be a better option for you. And these instances are available worldwide. All of our regions in AWS offer the T3 instance types. And then we have our T3a instance types, which are available now in over 17 regions, which are going to be expanding to all regions here shortly. So really giving you a consistent platform experience with the Burstable instance types across all of our global AWS regions. Okay, let's talk about our T3 instance pricing. So T3 is priced 13% lower than our M5 instance types. T3 has the 30% better price to performance than the previous generation T2, providing a significant amount of value on the T3 instance types versus T2. Then T3a offers the additional savings of 10% lower than T3. And then CPU credit price. So these are credits that you could purchase if your application needs it. It happens automatically in the background when we talk about the unlimited mode, and we'll dive a little bit deeper into how these are allocated. But the price is 5 cents per vCPU hour. vCPU hour is one vCPU running at 100% for 60 minutes, so fully loaded. And then that also is linear. So if you do 2 vCPUs running at 50% for 60 minutes, that's what the 5 cents will cost you for a Linux, Red Hat, or SUSE AMI. And then it'll be actually 9.6 cents for vCPU hour for the Windows AMIs. So the base instance price includes a baseline level of CPU usage and the ability to burst if your workload needs it. So the credits, which we're going to talk about, can optionally be purchased if more CPU performance is needed. And that's not something you have to go purchase. It's something you would opt into with the unlimited mode. And then the unlimited mode, which will automatically allocate the credits if needed, that is going to be the default state for the T3 and T3a instance types. And then 1 credit is equal to 1 vCPU running at 100% utilization for 1 minute. So the CPU credit pricing is the same for T2, T3, and T3a across all the pricing models for on-demand, reserved instances, and our spot market. We actually track the CPU usage of your instance at a microsecond granularity, and the CPU credits, which use a 24-hour credit bucket, so that brief CPU spikes do not lead to any charges. So we track this very, very carefully down to a microsecond level. And then based on the instance size you have, you're actually going to earn a different number of credits per hour. And then you also have a max bucket size. So the bucket size is how many credits you can actually hold on to in that instance. And then the credits per hour is how much credits you earn per hour. And then you can see here again, I'm re-showing the optimized for CPU usage column, which shows based on the number of CPU credits you earn, what level of CPU usage is going to be the optimized for that size. So for nano, you want to look at for less than 5%. For the micro, it's going to be less or equal to 10%. Small and medium, less or equal to 20%. And this is on an average 24-hour basis. So say if you're running a T3 instance, you picked, in this case, we have T3 large. It's optimized for 30% of usage. What happens if your CPU usage ends up going above that? You just had one day in the week where you ended up using 40%. So what we do is we look at how much you use. So in this example, your baseline CPU was 30%. Your average CPU for that day was 40%. So there's actually an incremental CPU usage that was accumulated by your instance. So this is now tracked and billed. And that's what's going to be billed with the credits that you can purchase that we talked about on the previous slide. So we talked about this as a bucket. We think this is kind of a nice way to understand how the credit model works. If an instance uses the CPU below the baseline rate, so your baseline rate is 30%, say if you're using it at 20%, that means you're actually earning more credits than you're spending. So this will actually fill up and accrue on your instance and will fill up to the bucket size. The bucket size being what will be dependent on the instance size that you pick. So the way to think of this is credits are earned at a consistent rate, which is determined by the instance size. So the number you earn per hour are determined by the size. And then you spend the credits as you use the CPU. And if you don't use as much CPU as you're earning, what happens is the bucket can fill up and it'll actually store these credits for some time in the future where you'll need them. But that number that you can store has a limit depending on the instance size. So then you can see here on the side, the credits are earned above the maximum. They actually do not accrue. And then you would just keep your credit limit at the max for your instance. If, for example, during one day, you had a very low usage pattern. So that's the unlimited mode. And we're going to talk about that more in a deeper dive example. But there's also something called the standard mode. So the standard mode is still available. It's what T2 will default at and provides an option for you that you're not going to pay for any more additional usage. So say you have a T3 large and you're running at 30%, even with unlimited or standard, you wouldn't pay for anything additional. But if you went over 30% and you needed more, what happens is we'll actually keep you at 30% to make sure you do not go over your allocated level. So the instance cannot exceed that baseline level CPU usage. And then you can flip between the standard and unlimited mode at any time. So say if you've been running in standard and then you know that there's a high volume or a need for more performance given an event that might be occurring, you can actually switch to unlimited mode. So that way you are prepared. And then you could always switch back to standard afterwards. So we provide a lot of flexibility going between these two modes. So now let's get to the meat of it. We really want to talk about when is it lower cost to use T3 versus an alternative option, which is an M5. So an M5 instance type allocates the full performance of the vCPU. So think about you can run it at 100% utilization for as long as you want, as long as you're running the instance. There's no concept of credits required. For T3 large, this is where you need to be very aware of how your application runs and to make sure you're picking the right T3 size to then yield significant savings for your bill. So here we're talking about T3 large. So you can see the baseline for T3 is that 30% mark, as denoted by the dotted line. So if your application sits at 30% or even below, you're going to be very happy. This means that you're actually going to be saving, we talked about up to 13% on the T3 instance type compared to M5, which is a nice slash in your bill. And you're not going to see any difference in performance because you're running within the baseline, which is what's allocated to your instance. Say you do end up using a little bit more, probably more than you thought you would, but you still kind of fall, in that, 40% range. You're actually still going to be better off, lower cost than what you would have with an M5. Here, the actual break even. The break even is calculated by how many credits you would need to purchase to where it's actually still more effective to use T3 large when compared to M5. This ends up being at 42.5% on average CPU usage. So when you're at 42.5 or lower on average, you're still going to be happy because you're not going to be paying any more than you would by using an M5 large. All right, so let's go to the other extreme. Let's say you launch a T3 large and you're running at 100% all the time. This is not what the T3 was intended for. So what happens is you're going to actually be paying 1.5 times the price of an M5 large. This is because you're going to have to purchase so many credits that to run at the 100% all the time that you end up actually spending more than you would if you just got an M5 large. So if that's you and that's your workload and you know that you're running this high performance computing or really, really significant simulation that you're constantly running, you probably want to be on an M5 large where you have this dedicated vCPU performance instead of a T3, which gives you the variability. So you're going to be pretty sad on a T3 large when running at full CPU usage all the time because now your bill went up, which is not the intention of what we did here with the T3 instance types. So here's some of the math of how this is allocated or calculated. So if you look at a T3 large size, it has 2 vCPUs. Here's the price per hour in column C, and then the M5 price per hour in column D. So the difference in price you can see there is going to be 1.25 cents per hour. With T3, you're going to get a base CPU percentage of 30%. The cost of credits for an hour's worth of usage is 5 cents, which means that each credit is actually 0.0833 cents. That'll give you 15 additional minutes. Then you look at the additional CPU percentage available, which is 12.5%. That's how you get to the 42.5%. So effectively, in English, the difference in the M5 price versus the M3 price, if you take that amount of money that you would spend and convert that to how much more CPU usage you can get by just buying credits, it ends up being 12.5%. That's how we get to the break-even CPU percentage of 42.5. And this calculation is the same for the different sizes, obviously the different price points. But you can see here that the break-even is 42.5 for the T3 large, and then 52.5% for the extra large, and 52.5% as well for the 2 extra large. And these are all prices based on the US East 1 North Virginia region with Linux OS. So next I want to go into a T3 example where you can actually see a workload running on the graph and show how the different components of what we talked together about when you talk about the instance price, the credits, the CPU utilization, how that all comes together. So that way you get a better understanding of how this instance type works so that you can save money. So for the first one, the graph starts at 0 hours. The instance is launched as unlimited. and immediately begins to earn credits. The instance remains idle from the time it is launched, so the CPU utilization is 0, denoted by the green line, and no credits are spent yet. So all unspent credits are accrued in what we call the credit balance. So for the first 24 hours, the CPU credit usage is at 0, and then the CPU credit balance value reaches its maximum of 144 credits. So this is a T3 Nano. So the T3 Nano has a baseline CPU percentage of 5%, and then it can actually hold up to 144 credits, denoted by the graph on the left-hand side. So for the next 12 hours, your CPU utilization is at 2.5%. So this is still below the baseline of 5%. So this means the instance still earns more credits than it spends, but the CPU credit balance cannot exceed its maximum of 144 credits. So because you're below the base, you're actually accumulating credits here, even though you're only running at 2.5%, but the bucket's full, right? You can only have 144 credits for the size. You're not going to get any more, but you're also not spending any, which is good, which means you have your full balance ready to go whenever you need it. So for the next 24 hours, you need 7% of the CPU utilization. So this is all above the baseline. Remember, the baseline is 5%, which is denoted by that dotted orange line. So this requires a spend of 57.6 credits. This means the instance spends more credits than it earns, and then the CPU credit balance value reduces to 86.4 credits. So you can see the blue line come down because now that you've had to use some of the CPU, you now have to spend some of the credits beyond what you would earn, which is still not a problem. You're still within the base instance pricing because you had credits already saved up from not using the T3 Nano instance in the first part of this, and actually first and second part. Then for the next 12 hours, your CPU utilization decreases to 2.5%. So this is once again below your baseline of 5%. This requires a spend of 36 credits. But at the same time, the instance is still earning credits, which is they're earning 72. So the instance earns more credits than it spends, and then your value or your CPU credit balance increases to 122 credits, as denoted by the blue line in the chart. So for the next 5 hours, what you see here is the instance is trying to burst up to 100% CPU utilization. You need this huge spur in CPU performance to run some workload that you're doing. So what happens is you will actually deplete all of the credits you saved up, which is denoted by the blue line, by running the CPU as high as you can. And then when you run out of credits, what happens is you're actually going to be brought down gracefully back to the baseline CPU that your instance is optimized for. And then with a T3 Nano, this is going to be the 5%. So now you're running at 5%, and the credit is no longer accumulating because you're using the optimized level of 5%, but you're also not spending any because you don't have any left to spend. So then this is what it'll run. So you can be brought down to 5%, you'll run your workload there, and then next you're done running your workload, and then you bring your CPU utilization down to 0%. So it's running idle now, waiting for the next thing to occur in the application, and then for the next 24 hours it's waiting, and then you can see that your CPU balance has now earned all the way back up to your max earned credits of 144. So that's standard mode. So you can see when you ran out of credits, what standard mode did is it said, we're going to bring you to the level that your instance type is optimized for. Now, with unlimited mode, this provides another concept of what we call surplus credits. Surplus credits are essentially like an IOU of credits, so that way your application can continue to run. And then you could actually be purchasing credits, so that way you can run even longer, even beyond a surplus, as long as your application needs to run. So why would we do this? It allows instances to burst at any time and pay down the consumed credits within 24 hours without being charged. So this essentially allows you to use 2 times the size of your burst bucket for a very, very intense period of time. And then if you know you're going to go back to idle, as you earn credits, you start paying back the surplus, and then you start building back your own bucket. And this means you actually don't even have to pay for any additional credits used. So it's essentially an IOU that you can actually work down within that 24-hour rolling window without having to be charged. But however, in the case that you are charged because you haven't earned as many credits as you've spent, that's when we get to that 5 cents per vCPU hour price point. So let's do the exact same example, but look at with unlimited mode on and the surplus credit balance shown here as well. So in this case, for the 5 hours, you're running at 100% CPU utilization, and then the total spend of credits is actually 570 to sustain the burst. So about an hour into the period, your instance completely depletes its entire balance of 122 credits, and then starts to spend the surplus credits to sustain this performance level that your application requires. So this totals 448 surplus credits in this period. So this is the 570 minus 122. So then when the CPU surplus credit balance reaches a value of 144, which is the limit for the T2 nano size, any surplus credits spent thereafter cannot be offset by earned credits. So you've spent the credits that you have in your bucket, and then you've built up this surplus credits or this IOU of credits up to the max, but you still need more. So the surplus credits, which totals to 304 credits, so that's the 448 minus the 144, results in this small additional charge at the end of the hour for the 304 credits. So for the next 13 hours, the CPU utilization is at 5%, so denoted by the green line. You can see here that your surplus credits with the red line is still maxed out at 144. You can see that your blue line of the credit balance, you're not actually earning any credits because you're running at the baseline performance. And you can see the surplus credit charged, which is denoted by the aqua line, based on additional credits that you needed even beyond your surplus. And then for the next 24 hours, the instance is idle. And during this time, the instance earns 144 credits, which is used to pay down the entire CPU surplus credit balance of 144. So you still don't have any credits left in your specific bucket, but you've paid down the complete surplus. So now at that point, at that 6 p.m. point at the very bottom right of the screen, if you started running your application at 5%, you would be able to spend credits as much as you earn, or if you're below 5%, you would actually start building up your CPU credit balance, which is the blue line. So given all that, I thought it'd be useful to talk through a couple areas where the target workloads, we've seen a lot of success with customers running on these T3 and T3a instance types. So speaking from a higher level, think about some of your general purpose workloads that don't really need fixed CPU resources. We work with quite a few customers who are getting very intelligent at doing this, either with their own monitoring tools, a third-party tool, or being able to leverage the free CloudWatch service as part of the instance type to start watching and monitoring for efficiency for what your instances are actually running. And I challenge you to go do this. Looking at some of these slides earlier in this webinar where I talked you through on how to get to that page, it'd be quite interesting to learn, especially given my hypothesis by working with customers that many instances that are running today are well underutilizing the specific CPU resources. So applications that occasionally need quick access to the CPU. So this is, think about it, something that's running idle a lot of the time, and then you have some spike in usage. So one workload specifically we'd like talking about that's easy to understand is like a code repository. You're sitting there, you're running, and then someone wants to go do a get or a put to get some of the information out, or submit some new changes. That might require some CPU, but then it's largely sitting there idle, just waiting for those requests to come through. Similar like mobile applications as well. So idle or moderate CPU for the majority of the time. That's another good indicator to look for. So average CPU is the key one, but then you could also look for how long it's idle. That might also be a really good indicator for what a target workload that you're running today. And then if you need it to burst whenever and for as long as needed, that's another great use case. So you don't have to worry about those times where you actually do need a lot of CPU. So what are some of these workloads? So microservices are great for this. We actually see that a lot of microservices are usually bound on things like input-output, talking to a database, for example. So those would be great because they just don't need the sustained CPU performance because they're not really doing anything. They're more waiting for feedback about a customer's account, for example, retrieving data, logging new data. That's a great area. Code repositories we talked about, interactive applications. So these are ones where you make a request and you expect some feedback. Once again, sitting idle, just waiting for that to occur. Virtual desktops. If you think about your average day on a computer, you open up an email, for example, and while you're reading the email, your system is running background or are idle tasks. That's another great way to think about the use for this. Small and medium databases, similar thing, where they do a lot of processing only in the limited times of the month, for example, or times of the day. And then dev and test, I think that's a great area to get exposed to how T3 works, but definitely not limited to that category of workload. We see many customers successfully run these in a production environment. So there's many more workloads. I just didn't want to leave it with general purpose. The way I think about it and the way I talk to customers is try any workload that you're running that you find out the CPU is underutilized. It could be a great place for you just to explore, run a little experiment, and then you can see that the cost savings could add up. 13% lower price than an M5, comparing T3 to M5, and then an additional 10% lower price comparing the T3a to the T3. So some pretty significant cost savings here that could be yielded by doing some pretty minor tests and to see if your application responds well, or even checking some of those metrics like CPU utilization. So let's talk through some of the questions that we constantly hear before we jump into some Q&A. So what are the burstable instances? So these are instances that are intended to offer lower prices, targeted specific at workloads that underutilize or do not use the CPU, all the CPU usage that is allocated. So the T3 and the T3a family specifically are the latest gen, these burstable families, offering you the most significant bump in price performance, up to 30% for T3, and then the lowest cost points with T3a, really getting down 10% cheaper than T3. So when should you use T3 and T3a? You really want to think about your workloads that don't consistently use the CPU. So these are any type of bursty or non-sustained CPU patterns. So the burstable workloads that we talked about, there's a broad number of workloads, but some of the ones that we've seen significant success is the microservices, your small and medium databases, and virtual desktops. How much will you be charged? So the T3 and T3a, these are latest generation burstable instance types, and they start in unlimited mode by default. That's to ensure that your application has the best experience and gets as much CPU as it needs and when it needs it. If your application only uses the baseline level of CPU on average, then you'll only be charged for the instance price, which is the same as any other instance, as listed in on demand or reserved or spot. If you're in unlimited mode and your application needs more credits, even beyond the surplus credits that we talked about earlier, you'll be automatically allocated those credits and purchased for the best application experience. And then if you run in standard mode, you'll only ever be charged for the instance price as listed, and no additional credits will be purchased for your application. So how much you'll be charged is going to depend on your choice between unlimited and standard. Standard would only be the instance price, and unlimited mode would be only if you go over your allocated credit balance. You can get charged small amounts for additional credits to run your CPU at high CPU usage. Are there AWS services, or which ones support burstable instances? So there are a broad set of popular services that support the burstable instance type. So this includes Amazon Relational Database Service, or RDS, SageMaker, Elasticsearch, Elasticache, some of our popular microservice like ECS, or Elastic Container Service, and Amazon Kubernetes Service, or EKS. And there's many, many more. So these are broadly available across our AWS service ecosystem, as well as our regions. So they're available in all different AWS regions. So wherever you're running your workload, if you're running them in multiple regions, there's going to be burstable instances there for you to use. So a quick recap. So the T3 and T3a offer much lower cost points for your applications, specifically those that are underutilizing compute resources of the instance. They're optimized for a broad set of production workloads, so they can sustain up to high levels of CPU use indefinitely with the unlimited mode, or giving you a fixed price for the standard mode, which are optimized for different CPU usage levels. They're globally available in all AWS regions. And the burstable instances offer all different pricing models that we offer with EC2, including the on-demand price, reserved instances for longer term 1 year and 3 year use at a significant discount, as well as our spot market. So thank you all for joining me today. It was a pleasure to be able to talk to you about some of our burstable instances and some of the significant savings you can actually achieve by adopting some of these. And now I wanted to open it up for any questions.